All right. So what we don't want to do is what? Somebody tell me one thing we don't want to do. If you watch the video. We don't want to heat it past 75, right? Because we want the calcium oxalate to be a hydrate. So we don't want to heat it past 75. And what we don't want to do is just do the experiment without the digestion step, because the mass is going to be off if we do that. All right. So let's go down here to. So all of this was right. We're going to determine the mass of the filter. We're going to weigh all that stuff out, and then we're going to find out the mass of the limiting reactant. What's the excess reactant? And then once we figure out the limiting reactant, we're going to figure out the number of moles of limiting reactant in the salt mixture based on the equation that we have, right? And then we're going to find out the mass of the limiting reactant in the salt mixture. I know that number because I made the mixture up, but we're going to determine it through the experiment. And then we'll find the percent limiting reactant in the salt mixture, all right? So, and all that's going to be based on the mass of the calcium oxalate that we isolate at the end, right? Because that's what we're trying to get to. All right, let me go back up here. All right, so you can see in the equation right here, calcium oxalate is here, and then potassium oxalate is here. So they are in a 1-to-1 ratio, right? So when we get calcium oxalate as the product, what we'll be able to find out is once we filter it and get the solid, the mass of that solid is going to tell me everything I need to know, because I can turn that mass into moles. I can use the stoichiometric ratio of potassium oxalate to calcium oxalate to determine the relationship between them, right? Once I figure out which one is limiting. Got to know what's limiting. The limiting reactant simply means that once it's used up, the reaction stops, right? You cannot do any further reaction without the limiting reactant being present. Once it gets used up, that's the end of it. All right, anybody got any questions so far? I'm running Zoom on 2 different devices, so hopefully everybody is good. And as long as you can hear me, then we're straight. All right, so let's go to the procedure, which is down here. I'm just gonna scroll down to it. You don't need to do the sample problem because we already put that. All right, so we have, let me take the camera over here so y'all can see what's going on. And let me stop sharing. All right, so we have let me turn my camera around too. So we have a 250 ml beaker. We got a hot plate. We got a thermometer. We got everything we need over here. So we're gonna go ahead and take this 250 and we're gonna weigh it. Hopefully the balance can go up to this mass. Yeah, the balance is the maximum mass is 510 grams. So we're gonna weigh this 250. And again, anytime you get ready to take the mass of anything, you wanna zero out your balance and then boom. So where it says in the report sheet, the mass of beaker, you should write this number down, 92.66 grams. All right. And so for the mixture, let me go ahead and add that. And again, we got a little bit more than a gram because I wanted to make sure that it was off enough. So we're going to add this potassium oxalate and calcium chloride mixture into the beaker. And it's settled at 92.65. So write that instead of 66, use 65. 92.65. All right, so I'm going to add the salt mixture right to it. And you can see the mass of the salt mixture plus the beaker is, can y'all see that? 93.81. Let me turn this other camera off. That's really throwing me off. So it's 93 point, let me see. You always want to wait for it to stop moving. 93.85. Let's go with that number. 93.85. So that's the beaker plus the salt mixture. So what's the mass of the salt mixture that I added? How would you determine that? What do you think? Just subtract the numbers. What do you get? Is it 1.19? One 1.2. All right, so we're good. So 1.2 grams is the mass of your salt mixture. And that salt contains both calcium chloride, which is here, and potassium, let me get to the camera, potassium oxalate. I want you to write these numbers down too. So the molar mass of calcium chloride, you're not gonna be able to see it on the camera because it's written, it's too small, is 147.01 grams per mole. Let me see if I can get close enough. Can you see that little number where it says MW?
Wait, what was the mass of the beaker?
The mass of the beaker, 93.8. I'm sorry, 92.66. Yeah, we changed it. It stayed more stable at 6.6. So the mass will go down to 1.19 instead of 1.2. Right? Can y'all see that little MW? Do y'all see that, or is it too small? All right, so the calcium chloride
it's
molar
too
mass.
small.
Okay, I got you. Calcium chloride molar mass, 147.01 grams per mole. Remember, if we know the molar mass and we know the number of moles, we can get the number of grams. And we can always get the number of moles from the grams if we know the molar mass. We can interchange between them. For potassium oxalate, the molar mass is 184.23 grams per mole. All right, you need both of those numbers because you're gonna have to interchange or interconvert between moles of potassium oxalate and moles of calcium chloride and moles of calcium oxalate, so on and so forth. All right, we okay so far? Everybody good? Thank God. Well, let me be quiet. I ain't gonna say anything about the feed. All right, so now we have our salt mixture. We have it in an Erlenmeyer flask. We're going to come back over here where the hot plate is, right? And then we're gonna go to the next step in the procedure, which is we added a gram. We're gonna figure out the percentage later on. We need a 400 ml beaker filled up with deionized water, right? And we already, the acidity of the water and all that stuff has already been tested. So we're not gonna do that step. We don't need that step. All right, but we're gonna I'll do the pH just so you'll be able to see that I'm not lying to you. So we go over here. So we're just gonna use the regular purified water, and I'm gonna pour Pour that here. Fill it up. And then, so here's my pH paper. If it stays red, it's acidic. All right. If it turns blue, then it's basic. Let me take that back. Stays red is neutral. If it turns blue, it's basic. All right, so we're gonna just test the pH of the water. It should be neutral, not tap water. You can see that it didn't change at all. All right, I dipped it into the water and the water is fine. What you expect, right? You don't expect purified water. Spring water may be a little alkaline, but purified water, you expect that to be neutral, and it is. So we've done the pH check on our water, and now we don't have to do any adjustments. We don't have to add any ammonia. And then now we're going to take 150 milliliters of the water that we just measured out. All right. And we're going to add that to that flask. So 150 mils. So you can see here, I'm not going to eyeball that. I should have got a bigger graduated cylinder. So we're going to take a graduated cylinder, which is a 50 mil graduated cylinder. You can see that top number. And I'm going to just have to fill it up more than once. So I'm going to do 50 mils at a time. And I'm going to go to pouring. I'll stop right at 50. Anybody disagree? All right. So I'm going to add that to here. All right. This will be 100. Need some music or something, man. This will be 150. All right. Everybody good so far? Any questions? So I added 150 milliliters of water, and it said this. I wish I had a stir bar to drop in here, but I don't think I have any up here. So it says stir for 2 to 3 minutes. So I'm just going to swirl it. Can you put me on a timer? 2 minutes. I'm just going to swirl that around. You can see it's all milky, right? Which is what you expect, because when you add these two together, the calcium oxalate that you get is insoluble. It's an insoluble solid. So there's a lot of calcium oxalate floating around in here, but we want to isolate it. So we're going to mix it, excuse me, then we're going to digest it. Let me see if I can see it at the bottom. Try to turn the light on so I can see it. Yes. All right. I want to show you this if I can get the camera angle right. Can you see at the bottom of this flask? Can you see that little solid floating around at the bottom? Hold up. Let me pull up Zoom on my laptop. So I'm gonna try this. Can you see it now?
Yes.
You see that solid floating around in there? That's your calcium oxalate. So when the potassium oxalate and the calcium chloride react, they form calcium oxalate, which is an insoluble solid, so that it precipitates out of solution. Yeah, 2 minutes up. Oh wow, that was quick. All right. So now after we stir for the 2 minutes, and we're going to go to the next step, which is we gotta heat it. All right. So it says here, add 150. Boom, let it settle. So we're gonna let that sit. He hit me with another 3 by 3 minutes. We're gonna let that sit, and then we're not doing a trial 2. If you're following along on the procedure, we're not doing trial 2. So it says cover and heat, but you don't want it to go past 75. So what we're gonna do is we're gonna get that up to 75, and I got another hot plate that I'm gonna use for that. All right, so I'm gonna go ahead and start heating up that other water. I think it said to heat up. Never mind. We'll do. It said 50 mils. All right, that's what I need to see. So I'm gonna take another Erlenmeyer flask, and I'm gonna take that water and start warming it up, so we can be efficient and we're not just like watching paint dry. Even though the 15 minutes are gonna feel like that, so don't trip about that. It's just one of the things. All right. So you should see more. Yeah, you can see a lot more. Let me try to work this camera angle again so you can see what's at the bottom of this. There should be a lot. There's a lot more settling. So I'm gonna turn this way, lean it back. And you should be able to see a lot more. You see the calcium oxalate at the bottom?
Yes.
It's like a white solid kind of settling down at the bottom. So that's precipitating out nicely, and we're gonna let that sit and rest, because a lot of times when you're making crystals or when you're doing precipitation, one of the keys is to let the solution rest. If you keep agitating it, then those crystals are not gonna form and it's not gonna precipitate like it's supposed to. How much time we got left? So we're gonna let that sit for, we got a little bit less than a minute left, and I need to grab a watch glass. So hit me with another minute. I'm gonna run to the stock room and get a watch glass. Actually, no, never mind. We got one right here. Perfect. And I have a thermometer, because it's telling me not to heat it past 75, right? The reason for that is that the final product, you want it to be a hydrate. You don't want it to be anhydrous. If you heat it over 100, then it's going to drive off all the water, and you're going to end up with an anhydrous salt, and you don't want that. You want it to be a hydrate, because the hydrate matches what's in the equation. We're good? All right. So it says to heat it. So I'm going to turn, I'll just move the camera back to here. I'm going to put it on this hot plate, and this is going to be the worst 15 minutes of your life. So I apologize in advance, but we got to do the digestion step. We got to do it the amount of time it calls for, so that when the calcium oxalate comes back out of solution, we get the maximum yield. If we don't do this step, then the number that we get is going to be off. The mole-to-mole ratio, well, not the mole-to-mole ratio, but the percentages in the salt is going to be off also. So if that's off, then everything is off. All right. So the good thing about these little hot plates is that they are the real deal. So, and we only want to gently heat it. We don't want to boil it. So I'm only going to turn this up to about 4, right? And I'm going to let the hot plate warm up some before I put the flask on there. Otherwise, it's really going to be like watching paint dry. There we go. All right. So I'm going to let it heat up a little bit more. And if you notice, the hot plate is the covering over is ceramic. That's on purpose. It's a great, I don't know, you're an engineer, right? I did. Okay. Do we have any engineering majors on? No? Okay. Well, the material that the hot plate is made of is ceramic. It's like a ceramic type polymer. Yeah, very good conductive heat. Excellent conductive heat. So that's why you need something like that. They do make hot plates that have aluminum surfaces, but they're not very sturdy. They're not reliable. They have hot spots on them. This is very evenly heated. All right, so I'm gonna put this on here, and it says 15 minutes. So go ahead and start the timer, and I'm gonna check the temperature after 3 minutes. Let me know when 3 minutes pass. I'm gonna check the temperature. All right, I have my thermometer. I actually could heat this openly and just put the thermometer in there and make sure it doesn't go over, but I'm gonna follow the procedure. As I said, to cover it with a wash glass, and that's to keep any water from evaporating. Just in case it does overheat, you won't evaporate off any water. All right, because that wash glass is gonna act as a barrier. If the water goes there and it cools down, it'll drip back down into the glass. So we got a 15-minute period for that, and I'm gonna check the temperature after about 3 minutes, and then okay, and then we're gonna follow that next step of the procedure. We're gonna figure that out. We don't know yet. There's a test you can do for that, and what we're gonna do for the test, that's a great question. So let's think about it. I want y'all to be thinking in advance. All right. So with the limiting reactant, let's say we did the reaction and we added more calcium chloride. And when you added more calcium chloride, you saw more precipitate. What would that tell you? Think about it. If all the precipitate was at the bottom and then we added calcium chloride and you saw a little bit more come out of solution, what would that tell you? It would tell you that there's no calcium chloride left. Is that, you follow what I'm saying? Mm-hmm. So, and then by the same token, if we added potassium oxalate and a little bit more precipitate came out of solution, it would tell me that there was none of that left. Because the limiting reactant, again, once it's gone, the reaction stops. So if you add more of what was limiting, then you get a little bit more reaction. If you do it again, you get a little bit more. But if it's excess, right? If I add calcium chloride and calcium chloride is already in excess, then you're not going to see any precipitate because there's plenty calcium chloride left, right? So the limiting reactant is present in the smallest amount. When it's used up, the reaction is over. And the other reactant by default is the excess reactant. So it doesn't matter how much more excess you add, if there's no more limiting to react with it, then it doesn't change anything. All right, did that make sense to you all who are listening in?
Yes.
All right, please feel free to stop me. If you ever have a question about anything, just stop me and ask. Because I don't want you to feel like you just have to mute and be quiet. It's still a class. As long as you're not watching TV or doing something crazy, you can feel free to unmute and ask any questions that you want. Okay, I'm gonna check. So I'm gonna check this temperature, and once I do that, I'm gonna go ahead and do step 3, which is I'm gonna go ahead and weigh my filter paper because I want to know like what my filter paper weighs, so that when I get the calcium oxalate on it after I filter it, I can know how much calcium oxalate I have by just subtracting out the mass of the filter paper from the mass of that plus the salt. Right, so I'm gonna walk you through all those calculations too, because I have an Excel file set up for that. All right, so let me check the temperature real quick. And again, you just want it to be gentle heating. You don't want it to boil at all. And you don't want your thermometer to go to the bottom, because if it does, you're gonna get an inaccurate temperature reading. It's not. There we go. All right, so right now the temperature is only reading 30 degrees Celsius, only 30. So I'm gonna warm it up a little bit more, to make sure the digestion goes to completion. And so I'm gonna turn the temperature up on the hot plate just a tad. Cover that back up. Still got 12 minutes. So let me go ahead and weigh the filter paper. All right, so your filter paper is just this little, it's a little white disc. I know it looks like it's pretty tightly woven, but it's actually very porous, right? But you don't want it to be too porous because then you don't want small particles to be able to slip through. So your filter paper, once you weigh it, we're gonna set up a vacuum filtration apparatus, which is over here. I'm gonna show you all of that. So I'm gonna go ahead and weigh this, and I'll tell you what the mass is so you can write it down. So the mass of the filter paper is 0.18 grams. .18 grams. So while that's heating, I'm gonna show you the vacuum filtration part. So over here, you have what's called a vacuum filtration setup. You have a Buchner funnel, which is here, this little conical plastic funnel. And then you also have on that a stopper. And that goes into a vacuum flask, which is right here, right? It's called a vacuum flask because it's got a little nipple on the side where you hook up a vacuum hose to it. And it wouldn't really be a big deal except for the fact that it's hooked up to an aspirator on the sink. Can y'all see that? So there's also a nipple on this thing here, and you just hook the hose up to that. When you turn the water on, the water going past the hose is pulling vacuum, right? And so you get to set up, if you can, let me see if I can do this little trick. No, if it's good vacuum and you have on a pair of gloves with some slack in it, you can see a pull the glove down into the flask, but this is not that good. The vacuum here has never been that great. Did y'all hear that though? So it is pulling, it's just not that great. All right, so once this is heated for the proper amount of time, we're gonna filter it. Then when we filter it, we're gonna take the filtrate, the liquid layer, and we're gonna test it to make sure that we're gonna test it to figure out which one is the limiting reagent. All right, so we're still, how much time we got left heating wise? 7 minutes. All right, let me check this temperature again. All right, so right now we are at, and you can see, hopefully you can read this thermometer or see the thermometer. Right. You can see the mercury going up in it. Right now we're at about 42 degrees Celsius. So that's good. And you can see the water starting to condense on the side of the flask, right? So we just want to keep it consistently warm, and we don't want to heat it past 75 degrees. All right, that's the goal. Anything, once it goes past that, you're going to drive off the water on your calcium oxalate, and when that happens, that's trouble, right? Because then your net ionic equation changes. All right, anybody got any questions? Right? And let me go back to here. Normally in your vacuum filtration setup, what you want to do under normal conditions, you'll take your filter paper that you weighed out and just put it into the filter, into the funnel, and then you want to seat it, right? Because sometimes it'll move around and you don't want that. So you're going to take a little bit of water and just drip it on there to seat it so that it'll sit flat on the in the funnel. All right, so you can see the filter paper is wetted, so it'll sit and it won't move around. That's important because one of the biggest mistakes that you can make when you're doing a filtration is to allow your product to go over the sides of the filter paper. So you don't want to do that. So you want to keep that, excuse me, that filter paper seated so that nothing can get over the sides. All right. And how much time we got left? So we got 4 minutes left before we can do the next step. All right. And that's what if you look at the filtration part, number one talks about the vacuum filtration apparatus and sealing that filter paper down by wetting it with some water, right? You want to wet it because again, you don't want any of your product to go over the side. All right, and I don't think they gave me any test tubes, so let me go grab some test tubes while we wait. All right, give me a minute. Right to the stock room.
Yeah, I'm in the lab. It's on Zoom, what it's called. Tell me how I didn't know that I wasn't supposed to show up. I'm about to do go step on 2 hours. I'm gonna take serious and you can give me. Yeah. I got you. No, I got most more written down too. I bet.
I couldn't find test tubes, but I found some sunilation valves, so we'll use that. It's just a little valve right here. You'll still be able to see what you need to see. Check the temperature again. A minute 30. Turn that off. I don't want it to overheat. These hot plates are notorious for they'll start out gentle and then you look up and the temperature get 100. Yeah. They do that a lot. So it's always good to keep tabs. All right, so right now you can see the temperature is at, get at an angle so you can see the mercury. It's at about 57 degrees. Can y'all see the mercury in there?
Yes.
Yeah, so it's at about 57 degrees. So that's good. I actually turned off the hot plate because we only got a minute left and I don't want any mishaps. And when it gets out of the way, we're just gonna keep it on the hot plate because the hot plate is still warm. We're gonna keep it there and let it finish. Anybody have any questions? This is probably, other than the standardization lab, this is the hardest lab of the semester. That's what, but I wanted to do it because by now you should have a little bit more dexterity with those calculations and balancing and mole-to-mole ratios and all that stuff. You should be more adept at doing that now. So that's why I wanted to do this lab today, because you get to use all your skills, all your deductive reasoning, everything, all tied up in one lab. That's it?
Yeah.
All right. So we've heated it for 15 minutes, and you can see this is awesome. That's why I love chemistry. All right. You can see here all that. You see that how much more is in there now? At first, we started out with just a few little pieces of calcium oxalate, and now look at the bottom. It's almost covered with calcium oxalate. Yeah, yeah. So that's why, again, that's why that digestion step was so important, because if you didn't do that and you get out, say, 200 milligrams of calcium oxalate, when you really can get out 500 milligrams of calcium oxalate, you understand what I'm saying? Then when you do your calculations to figure out the mass and all that stuff is going to be off. Everything is going to be off. All right. Are we okay with that? Everybody good? There's a lot of calcium oxalate in there. You can see it now. I don't even have to move the camera. Right? You can see that how much of it is in there just by gently warming it up. All right. So we're gonna do the vacuum filtration. We already got the rinse water. I heated that up already, so we're good on that. We're gonna go ahead and do the vacuum filtration. I'm gonna let it cool down for about, hit me with about a minute or 2 minutes. Let it cool down for about 2 minutes. And the procedure says it doesn't have to be room temperature. It just needs to cool off a little bit, right? And it was only 50-something degrees anyway. So technically I could go ahead and filter it now, but I'm gonna wait. All right, so we're gonna wait about 2 minutes before we filter that. And then,
We also put on the lab simulations, like the simulations and like the report sheet.
yeah, you're gonna get those lafters are gonna be a part of your grade. And I know they're hard to do sometimes because of the size of them. They make my computer crash.
My problem is I've only done the simulations.
Yeah.
But I've done like the reports too, and I've done like all the simulations.
Oh, you talking about own lafter? No, you just need to complete it and get the certificate.
Also, like the reports, they like writing stuff down, like.
No, you don't have to do, not with lafter.
Oh,
Yeah, no.
the
Report sheets, we actually had like some labs that were done. They were recorded, but they were done and sent out. So you got data and all that stuff for chromatography, the stoichiometry lab that we did last week, physical and chemical changes, and there's one other lab that we did a video for, and then of course this lab. So that's the only thing you're gonna be turning in report sheets for. The labs, so you just do it, get the completion certificate, and take a screenshot of it, upload it to Blackboard. Yep. So I actually put in some more grades last night on in Blackboard. So y'all should see some updates to some of the stuff you turned in and things like that. The crazy thing is though, it's like 20 something people in the class. But when I checked Blackboard last night, for the last experiment we did, only 8 people turned it in. So I mean, I know that it's been weird because we are virtual, but it's still a class and the work is still due. You know what I mean? So I don't know. Yeah.
Dr. Russell,
Yes.
can I ask you a question?
Depends on what you about to ask me. I don't have no money.
No, I was just gonna say, I did look at where you said you was putting the assignments in, and I saw that for like one of the earlier assignments that I had a 0, but I actually turned it in. So I think the problem was I turned it in under the wrong Like
Right.
I turned in 2 assignments under the same
The same link.
folder. Yes, sir.
Okay. All right. We can work it out. I'm
Okay.
not a jerk. I pride myself on not being a jerk. We can work it out. If you turned it in, but it's just in the wrong place, that can be fixed.
Okay.
I'm just talking about people who ain't turning nothing in. That can't be fixed.
Mm-hmm.
But yeah, we can work that out. Don't worry. Don't sweat that.
All right. Thank you.
All right. So now I think we're ready to filter. So we already got the vacuum filtration apparatus set up. You can see the hose. You can see the buccal funnel, the filter flask, the stopper, and all that. All right. So what we're going to do is filter it. All right. So it says here, set up a vacuum filtration apparatus, blah, 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 seat it, seal the filter paper. And it says once the precipitate has settled and supernatant has cleared, which we've done, right? It says label 1, calcium chloride, and the other potassium oxalate. And remove 1 milliliter of the supernatant and transfer. So let's do that. I don't have a Sharpie, but we can do this. So we're gonna take these. I'm gonna put it over here, and I'll move the camera because I do have these solutions made up.
Dr. Russell,
Yes.
I have a class in 10 minutes, so I don't think I'm gonna be able to stay.
You got a class. Boy, I tell you, this semester's so screwed up. All right.
I tried to get that fixed on my schedule, but it was.
I know. You don't have to explain it. The video will be on YouTube tonight.
Okay.
I'm recording this. That's why I brought my laptop so I can join the meeting from 2 locations and record. So it'll be uploaded to YouTube. You'll be able to see the last part.
Okay. Also, that's the reason why I couldn't do the last lab that we did on Zoom, because I had to end up leaving, and then the connection was really bad, so I could barely understand what you were saying.
Yeah, that lab, I'm probably just gonna not count it because the connection was so bad and Zoom kept going in and out. So what we'll do is we'll replace that lab with 1 more Labster simulation.
Okay.
And then call it a day. That was horrible. And I don't think it was recorded either. So don't sweat that. I'm gonna I'll send an announcement out tonight with some details. I'm gonna send the Excel file so you can fill that with the numbers filled in, so you can fill in your report sheet, and I'll have the video uploaded. So you good.
Okay, thank you.
Mm-hmm.
I have a question.
Go ahead.
Did we ever do the air dry, the mask of the air dry thingy, or no?
No, we can't do that until after we filter it.
Okay.
You understand what I'm saying? The air dry filter paper is the filter paper plus the calcium oxalate that we made in this experiment after it's sat and dry for a while. So what I'm gonna do is I'm gonna have that number, I'm gonna include that number in the Excel sheet that I send you. Right, because if you
filter paper yet?
Yeah, the mass of the filter paper is 0.18 grams. But all that's going to be in that Excel file. So anything you didn't get, you'll have it when I send the Excel sheet or when I upload it.
Okay, thank you.
You missed the bus to go back to Auburn? Man. Okay. Yeah, as long as you got a ride, bro. If not, I can get you an Uber because you came a long way. Even though the email said nobody was supposed to come. Well, that was just, the video was just for informational purpose. That's okay. If your roommate can't come, I'll get you an Uber, bro. Don't worry. We'll make sure you're straight. All right. So we're gonna take out, and you can see here I have that label, calcium chloride, and I have the other one labeled potassium chromate. Right? I'm sorry, potassium oxalate. I keep wanting to say chromate. And what I'm gonna do is I'm going to take out, you can see now this is starting to settle. Not that one. This is starting to settle, so it's clear. It's a little bit clearer. So if we add some potassium oxalate to that, or we add some calcium chloride to it, we're going to be able to tell which one is limiting. right? So we gotta, it's pretty clear at the top. So I'm gonna take some of that. It says take 1 ml of supernatant and put it, I need another dropper. Let me see. Let me grab another dropper. Give me 1 second. All right. Trying to break this thing. All right, so I'm gonna use a pipette to take some of that out because I don't want to contaminate the droppers. All right, so I'm just gonna take out. I don't know if you've ever seen one of these before, but there's a little wheel up top, and you just roll it to pull a solution up. So let me do that right quick. So here's my solution. I want some of that good clear stuff at the top. So I'm actually gonna take out 2 milliliters. I'll take out 3. What? So they counted Michigan for him? I think that's good, man. I'm sorry. I don't like talking about politics with people, but man, we done had enough of this foolishness, man. Yeah, man, we had enough of that, man. It's time for something different.
I feel like I placed the bet that was watching how it turned out.
Yeah. We had enough, man. We had enough. All right, come on, bubbles. You can see it's a bubble in there. I'm trying to wait for it to move.
What happens with like breaks like the last lab?
Who?
What happens with breaks like the last lab?
The stoichiometry one? I'm not gonna count it because the video is screwed up, and so I'm gonna replace it with something. You'll get a grade for it. Don't worry about that part. But I don't. That video is so screwed up, man. I feel bad about even trying to, I think you have the information numbers wise, but I mean, I'm gonna figure out a way to count it. I might just make it an extra credit lab. Yeah, but it's got to be dry though. So we're gonna do that. I'm gonna send y'all that information later. So once we filter it, that's gonna be the end of this lab. So that's that. I'm gonna do one more. Do this in here. All right. So what we're looking for now, this is the big deal, the big kind of shebang of the whole lab. If we add calcium chloride to this solution and we see more precipitate, then that means that calcium chloride is limited. If we add potassium oxalate to the solution and we see more precipitate, that means potassium oxalate was limited. Are y'all following that? Because if more precipitate comes out of the solution, what that means is that it needed a little bit more of the other reactant in order for that precipitation reaction to occur. Does that make sense?
Yes.
Okay. So I think I'm gonna try something here right quick. So I can put it up here. Trying to get the camera angle right so you can actually see the solution, whether it gets cloudy or whether it stays the same. So you can see the solution. It's pretty clear. So if it excuse me, clouds up, you'll know. You'll be able to see that. So this is the one we're going to add calcium chloride to. And then the other one we're going to add potassium oxalate. I'm going to add that. All right. So I have some calcium chloride right here, a solution. And I'm going to add it, and then we're going to see what happens to the scintillation valve that is labeled for calcium chloride. Got it sealed up with paraffin. And I'm only going to add a couple of drops to this. I don't know if you can see that, but I'm gonna pull it down. You can see that no precipitate form. It got cloudy because the calcium chloride solution was cloudy, but you don't see any precipitate at the bottom. Hold up. Right, you don't see any solid come out. It got cloudy, yeah, because calcium chloride is cloudy, but it didn't form any solid. Right, so what does that mean? Is calcium chloride limited or is it excess? Okay, so let me say it again. If you add more limiting reagent, you should see more reaction take place, but you didn't. You didn't see any new precipitate form. So that because the limiting reagent is used up at this point, right? So if I add it and I don't see any more precipitate, that means that what I added had to be excess. All right. So now let me add some potassium oxalate. I'm gonna add a couple of drops here. And let's see. Trying to see, I can definitely see some solid in here. It's faint, but I can see it. Hold up, let me I don't know if you'll be able to see that, but there is a little bit of solid floating around in there. It's not a lot, but what that says is that the potassium oxalate is actually limited. Because when I added it, right, then I got more of the calcium oxalate out of solution. Can't say the same for the calcium chloride. All right. Are y'all following that? We okay with that?
Yes.
All right. So now we know which one of them is limited, right? The potassium oxalate is limiting, and then the calcium chloride is excess. So we know that now. So now we can go ahead with our filtration. So I'm just going to set up the filtration, and then we'll roll. All right. So we're going to do the filtration, and let me see what's next. So we did our test. And that's the solid that's in there. It's kind of suspended, so it's hard to tell, but it's there. So the potassium oxalate is the limiting reactant. So you can write that down somewhere in your notes. And then I have it on the Excel sheet, which I'll send to you. You'll have all of that. All right. So now I just want to filter this. So let me move all of this stuff out of the way. And we're just going to turn on the water. And filter. And that is a lot. Look at that. That's a whole lot. So we're going to take this and filter it off. And you can see with the vacuum, you can see it, the liquid start to go down into that filter flask. All right. And again, this is like watching paint dry. So I'm gonna stop here and finish the filtration, and then I'll send you the numbers this evening. Probably when I get back home, because I got to drive back to Prattville. Or I may do it before I leave here. All right, but either way, that's the limiting reactant layout. So we ran the reaction, we digested it, and then we did a test to see which one of those two parts of the mixture, the salt mixture, was limited, and it showed to be potassium chromate. All right. Anybody got any questions? All right. If you don't have any questions, I'm going to end the. Let me stop recording first so that I can be processed. I can upload that before I leave.